Yeah, okay, so we were midway of doing something last time. We were doing this set simulated physics garbo. But it was giving us a null pointer from the sphere, and I'm pretty sure that has to do with recompiling. I think that's why it's sort of complaining that we did this like blueprint read. So I'm just gonna restart. You know what? It's always good to restart every once in a while. Get a fresh start. There we go. So now let's see what happens when I kill this guy. Where are you? There you are. If I shoot him. Yay! It works. Bye-bye. So now I can actually also give him a bit of... Bye-bye. Have fun. So I can do that. So that's cool. And he didn't actually grow in size, right? When I shot him. Can anyone explain to me why he didn't grow in size when I shoot him?
Didn't you override?
Yes. And what do I need to do to make him grow in size? In that case, like in code terms, I guess. If you override a virtual, how do you call like the super? You do super : right? And then the name, like in tick. Like this, right? So this is how you call the parent version of that overridden function. And it works kind of the same in blueprints. We will go in here. And the way you do it in Blueprint is that you right-click the event or the function that you've overridden. You right-click and then do add call to parent function. So that's now we have a node that's, you know, call the parent version of this function. So we'll do that. Always good to do. So now when I shoot this guy, he will also grow in size. That's cool. Bye-bye. Sick. So another way we could have done this. So instead of having like a base function we call in a base class that we then override in Blueprint, we could have done it like I guess that would be like the Unity way of making a component. So we make a component that reacts to getting shot at in some way. And then maybe that will send out an event or something that we can then subscribe to. This is generally the way we do that, Hazelight at least, when we want to do stuff like guns. So, you know, with the Sap weapon, maybe I can show it actually. So if I show like Hazelight, it takes two trailer.
This is Joe.
Oh, well. Let's see if I can get some stuff going here. So here you can see that he gets a sap gun here, the little boy here, Cody. So he gets a sap gun, so he's shooting these little blobs here at things. So they're doing something very similar, where they're going forward. So they're doing a line trace, but it's essentially the same thing as he's doing a sweep. But since there's a lot of different things you can hit in this level, like you can hit these wasps to blow them up, but also you can hit these swarms here to blow them up, and they're like a completely separate actor. But you can also do stuff like this. You can hit stuff in the level, and that sort of weighs them down. I know here you can also hit the match gun on these things, and here you can hit on this little straw thing, and then blow them up to make it explode. And these are very different actors, right? So you have wasps, and you have swarms, and you have stuff in the level that is supposed to be just level mechanic-y things. So one naive way of doing that would be to make some sort of like base actor for Sap hittables or something, and then have these all override from that. That would be one way. That would be like the object-oriented way of doing it. But I don't think it's that good of a way of doing it, because you're dictating exactly what type of base class it is. Like, okay, so maybe I want to have an actor, and then okay, so I have to make it. So then I have to override. So I have to make it like an actor, like a base Sap hittable actor. But then these are components. So then, okay, I might have to override from component as well. So this becomes very messy to do with inheritance. So the way that we did this for almost all the weapons in the game is that we made an actor component that was called something like a Sap Response Component. So what happened was that anytime I hit an actor with Sap, I would get to see if this actor had that Sap Response Component on it. And if it did, then I would call an event on that component that the actor could then subscribe to. So, the wasps had that component. The squirrels just shooting a cutscene. So the wasps would have that component on them, and then the wasp actor will subscribe to that event, and then get heavy, spawn this like little sap mesh here that's on the actor here, and do their AI to turn off chasing and so on. And the same thing with the swarm. They don't really do that much when I get hit, but they also had a component, and these ones had like, okay, if I get hit, it will also broadcast where on the actor got hit. So then these physics actors here would start simulating physics and assuming these have some sort of weight and simulate that. So they all could have very different behavior while still only having this one component on them. So the component doesn't really do anything. All it does is just have an event on it that you can subscribe to and do whatever you want.
Is this still the method of where they have this base actor which they override from, or is this another?
No, so this is with the components. So this is what we have an actor response or a Sap response component on them. So you don't override from that component, you just slap it on the actor and then subscribe to those events.
Okay, so each actor that shall be able to be affected by the goo will have like a goo reaction component.
Exactly.
Yep.
Exactly. So I think this is a very good way of handling these sort of things, and it's just like sort of good to learn how to do it in general. So let's do that. So let's try that sort of design pattern out to see how that would work. So first of all, we're gonna make a component, right? So we want to make a component on this guy, and that the bullet will search for, and then if it finds it, it will call an event on that component. So that's what we'll do. So I'll make a component. Whoops. Let's see, make some new files. Fuck source. Fuck. I guess we'll put it in play here, I guess. I'll call it fuck projectile response component. You can call it really anything you want, but I like the word response component. There we go. So I'll make one header and one C++ file. Put those in there. Remember to pragma your ones. So we'll do you fuck projectile response components. Public you actor component. So I'll make it an actor component and not a scene component, since I want this to affect the entire actor. So the entire actor will become sort of aware that it can be hit by projectiles. I guess you could make like a sort of a case to make it a scene component if you wanted to, but it will become a little bit more complicated, so I will just make it an actor component. Keep it simple. So I will include actor components. Let's see what that is. It's in components. So components, actor components. So include the generated projectile response component generated.h. Make it a uClass, blah blah blah, public, blah blah blah, generated body, and so on. Cool. Great. Let's just compile this and see if it exists. Let's see if we can actually add this. So I will compile. All right, so the compile was successful. Let's go into Blueprint just to see if we can actually edit it. So I will add a component, and let's see, fuck projectile. No, it's not showing up. It's only projectile movements. So it's not showing up here. And there's a reason for that. By default, actor components, when you declare them in C++, cannot be spawned through blueprints. They can be added to actors. So if I added it through code, it would still show up here. But we just cannot add it through this list here. And we actually have to mark this class to be blueprint spawnable. We have to mark that this is, for some reason, we have to mark it that it's safe for spawning. So we add this sort of, I think it's blueprint spawnable component. Let's just search for that for a sec. Spawnable compo. Let's see. Maybe it's blueprint spawnable. Let's just Google it, whatever. I don't trust the search function in Visual Studio. Blueprint spawnable UE4. Class specifiers. Let's check it out. There it is. Okay, so it was blueprint spawnable components. Great. So we have to put that in. Right, let's try it. Blueprint spawnable component. So let's compile. Uh-oh. Here it says unknown class specifier, blueprint spawnable components. So that's kind of weird. It says right here that it is. Your class specifiers. The problem is this is something called a metadata specifier. I am not quite sure why it is the way it is, but there's something called specifiers, but then there's also metadata specifiers, and the only difference really is that you have to type meta in front. So you have to do like this. So you type meta is equal to, and then in parentheses, all the metadata specifiers. So you have normal specifiers like abstract, and then you have meta specifiers, which are in this meta.
Sorry, one more time. Why do you need this?
I'm not sure exactly why they have split it up. So there's specifiers, normal specifiers, and there's meta specifiers. The only actual implementation difference I know is that these are stored as strings.
No, I mean, why do you need a blueprint spawnable?
Oh, you mean like that? Oh, that's because we cannot add it in here. We cannot add it. It will not show up in this
Oh,
list
right.
otherwise.
Okay.
So that's
So
why.
then, if it is added in the list, you would add the blueprint subclass of it, or you would add the C++ class
Yes.
into the blueprint.
Yes.
Which one would you add?
I mean, we're probably gonna add this in code anyways. But if we want,
No, but I mean, if say you have this component, you have a subclass of this that is a blueprint class.
Yep.
If you have this blueprint spawnable, will you then add the blueprint class, or will you add the C++ class?
then you can add either. If you override it in Blueprint.
Okay, so the blueprint class is always addable.
Yes, Blueprint
okay.
overridden components are always spawnable. Yes.
Okay.
Yes. Okay. So for some reason there's this meta equals. Don't worry too much about it. Just check in the specifiers if it's under the metadata specifiers. But yeah, so there's a bunch more here. I don't know. Unreal things. So now, if I compile, hopefully that should work. I made it abstract though, so let's not do that. That's not gonna work. Okay, let's try again. Cool. So now hopefully, maybe, if I type projectile, no, fuck, no. Let's restart the engine. You never know. Especially with the meta tags, probably this is a little bit shaky when it comes to reloading. Like remaking the list of components and so on. There might be something else that I've forgotten as well. Who knows? Alright, let's see. Go in here, edit blueprint, open in blueprint editor. Now maybe, project no, oh, I still can't find it. Why can I not find it? Maybe here? No. It might be because this is not even. No, it should be compiled. I don't think I need to do anything more. Let's add a C++. Let's just include it here just to be safe. See if that maybe jiggles it awake. So I'll just maybe make a constructor as well. I don't know. It's probably something I've forgotten. Sometimes active components can be a little bit finicky to get working. Let's try that. I added just a empty constructor. Maybe that will shake things up enough. It should have made a generated C++ file, so it should have been like compiled in. Okay, so let's see now then. Nope. Okay, let's Google. Help. Unreal.
This is super weird because it's showing up for me. My
Really?
code is. It looks the same.
Yeah,
Unreal
it shows
component
up
not
for me as
showing
well.
up. Let's see. No, it's not. It's something else. Impropriety. Let's restart again. Maybe, I don't know. Maybe we should just nuke intermediates. Yeah, let's rebuild. Actually, let's rebuild. Fuck here. But this is what it's like working in C++. I know this is ugly compared to Unity, but this is the way engines sort of work. Like no engine is unfortunately very pretty once you start dipping into the C++. There's always gonna be quirks and weird stuff. You sort of just get used to it.
Yeah, once you get used to it, it's much easier to do.
Yeah. Okay, let's see. Maybe, baby, if we cross our fingers real hard and pray to Jesus, maybe our dreams could just come true. So I will go into the blueprints. And come on. Yay! Okay, there we go. I rebuild it and then it works. Fantastic. Okay, cool. So now we have the response component here. So now we can start adding events to it. So we can see there's already 2 events here. There's onComponent activated and component deactivated. So there are 2 already, but we want to add some more. So we want to add some sort of like on projectile hit event or something that we can subscribe to. Like a delegate event. So to do that, we got to declare a delegate. Okay, so you guys remember the horrible delegate declaration macro. It is declare, if I can remember this maybe, declare multicast it's dynamic first. Dynamic multicast delegate. So dynamic means that we can hook up to it from blueprints, and that's what we want in this case. Multicast means that any amount of people can bind up to it. So it's an event in Unity instead of a delegate. And delegate, yeah, let's use delegate. So these two are required, and then these 2 in here define what kind of delegate it is. And then after that, we type how many parameters we want. So we choose one of these macros. So I guess we'll have 1 parameter. Maybe not. Let's have use no parameters for first. We don't really need it. And then we just type which name, the name of the delegate here as a parameter. So I'll just call it F. Fuck projectile on hit event. Very good name for it. So now we've defined a delegate type, a delegate event type that's called F fuck projectile on hit event. So that's the type. And if you guys remember the same thing as in Unity, you first have to declare the type, and then you have to declare a variable of that type that you can actually hook up to. So I will define here to be F fuck projectile on hit event, and I'll call it on projectile hit. Projectile. All right. Any questions about that? You like it? If I can like this shit? I see you're talking, Oliver, but I can't hear you.
Hello?
No? Oh, there you go.
Oh, okay, nice. Is that when you call like C++ code from blueprints? Or why do we use delegates and not just U function?
Well, a U function you can override in Blueprint. But remember, in the Sap gun example, there was all kinds of actors that were reacting to the Sap hitting it. Like there were enemies, there were obstacles, and so on. Which means that if we make this an event, then we can make whatever actor we want. Like for in this case, like we're making an enemy. And if it's an event in here, we can just subscribe to it. So we can just hit this plus button. And now we're subscribed to that delegate event. So now we can do whatever this enemy wants to do when it's being hit by something. Otherwise, we would have to like override the component and then like put that component on this actor, which is like an unnecessary other step instead of just having an event that we can just hook up to. And then we don't have to override anything.
Okay, yeah. So U functions are for actors, or if you want to override components, I guess.
Yes.
And delegates are if you want to write. Yeah, makes sense.
Yeah.
Cool.
If you want to hook up that. So both are, you know, bad in different situations, but in this case it's very nice to use a delegate.
Cool.
So I'm gonna add a delegate here. I'm gonna mark it as a U property. So let's see what happens. So if I compile, maybe I've never in my life declared a delegate on my first try. So probably oh, can I get an applause, please? I'm pretty proud about that. Thank you. I'm gonna have that on my CV, like made a Unreal delegate on the first try. That's it's amazing. However, it has not showed up on this list here, so boo. Wah. And the problem is that by default, for some reason, Unreal is so fucking paranoid about blueprints. It is not bindable by default. So when you declare, even though it's declared as a U property, it is not bindable by default. Same thing that variables are not visible by default or not editable by default. They're just visible to the engine. So we have to add a specifier to actually make this an event that they can bind up to. And it's called, let me Google. I mean, let me remember. I'm thinking right now, I'm not Googling. I've stopped sharing my screen, so you shouldn't be able to see this. It's called Bindable UE4? Maybe? Oh, that's not what I want. Okay, let's do, let's check out property specifiers. I think it's something like assignable, maybe? Oh, there it is. Okay. Blueprint assignable. Usable with multicast delegates only. Exposes the property for assigning in blueprints. Fantastic. So this blueprint assignable is what we want. So I will declare it a blueprint assignable. Assignable. So now this should show up in the event list. Let's see what happens. Still first try though, this doesn't count. This doesn't count. This was on purpose. There we go. Whoa. Okay, that looks pretty good. Just not gonna worry about that. Hey, there we go. Here we go. So on projectile hit is now an event that we can bind up to. So I will just boop. And now we have this event here. Very cool. So let's, instead of doing this on take damage inherited function, I'm just going to use this on projectile hit instead. So now let's see what happens. Any predictions about what's going to happen?
Probably nothing, because the event isn't being called, right?
Good point. Good point. So is nothing gonna happen when I hit him?
Well, it might activate the base function that you have in the CPP, so it's gonna grow larger, but it's not gonna do anything new.
Let's check. Good prediction. So yeah, it's still calling the base version, but since we're not even calling the delegate, that's not being taken into consideration yet. So let's actually use the delegate that we have. So let's head over here. So now instead of casting to this base actor, instead of doing that, we're gonna check the actor to see if it has this response component on it. And if it has the response component, then we're gonna call the delegate. So instead of casting, instead of doing this nonsense, I'm going to actor find component by class. So again, like in Unity, this will search through all of the components and see if it finds one, and then we'll just take the first one, that is this class. And I will, in template, I will add u fuck projectile response component, like so. I'm gonna include it, so I will include it, like so. And it will return a pointer.
Wait, did you just include a header file of the... Wait, so the delegate creates a new header file? Or...
I just included a component header file.
Oh, okay, never mind, yeah. Cool.
Yeah, it's still fine. So, response component as a pointer. This got deleted. Thanks, Visual Studio. So there we go. Now we're finding if the actor we're hitting has this component on it. Of course, it might and it might not. So we gotta if check that. So I'll just if check. And if it does, then we will get the on projectile hit. We'll get delegate, and then to call it, we do this broadcast here. So broadcast will just fire off the delegate to all the bound functions. Does this make sense?
Yeah, what you're essentially doing is trying to find a response component if there is one, and if there is one, we use it.
Yes. So you can see that as having a component in Unity that has an event on it. So this is just like get the component, and then if there was a component, then access the event and call it. So let's see now what happens. Here he is, and if I shoot this guy, I haven't compiled. It's embarrassing how often I forget that. Okay, now let's see. And now if I hit this guy, yeah, there we go. So now he is only simulating physics. Shoot this out. Oh, fuck. Cool. So that's events, and now we also learned how to make our actors, or actor components, and how to find those. So that's very nice. Any questions before we take a break about what we have just done? Crystal clear? Sick.
But okay, never mind.
Okay.
I can look at the constructor again for the components.
Yeah, it's empty.
Alright, cool.
I said
Nice.
this is like coax Unreal to do something.
So this is basically just to get the event visible in the blueprint. So if you would do it in code, you could just add this declare dynamic multicast delegate on every actor.
No. Or I don't. What? Could you repeat that?
So why are you doing this in a separate class? Like, couldn't you just declare that dynamic like that delegate that makes the like how? I probably just have to look at the code. I don't quite follow why do you need this class? Like why can't you just do that? Put that event variable on the others? Yeah.
Well, if we put this on the enemy, like we had before, then if the level designers want to use your bullets, so they want to say like, oh, okay, I want to make a door, right? So I want to have like a door that they have to shoot, and then the door goes away. What's so nice about this design pattern, if we have this response component, is that they can just make a new actor here in BP. So just make like just a base actor. You don't have to override from anything. So just do like a B door. So now that they have the door, all they have to do is just add the response component, right? And then just override on projectile hit. So they will just get this event. Let's say like, oh, I want to have a cube here, like a big cube.
Right. Okay. Yeah, you explained that before. I'm sure. I just.
No, but it's good to hammer home, like, why are we doing this? It's more complicated, but well, it's partially just to teach you guys about how to make actor components and how to make delegate events. That's partially the reason, but also the reason is because I think it's a very nice design pattern that we've used a lot at Hazelight, and it's made a lot of systems easier to use for designers. So now they made a door, like it's completely blueprinted, and they didn't need to override anything. All it needed to do is add a component. But now if I shoot the door, it explodes. So that's very nice to avoid having a bunch of base classes that gets, like, you know, overly used and bloated, which is very sweet.
Can you go on with or like re-explain the dynamic and multicast things on the delegate? What does that mean?
So declare and delegate are just like how to make a delegate. And then this means dynamic. This means that it can be bound by a blueprint. That's essentially what the dynamic means. So if you skip the dynamic, it will still work, but then it's essentially a code-only delegate. It's something that can only be bound by code. But dynamic means it will do, like, you know, type lookup, and it will work to bound from anything. Multicast means that multiple things can bind to it. So if you don't have multicast, then essentially it's a function pointer. That means, like, you can set it from blueprint, but it will only ever point to one function, and that's all it can point to. With multicast, then you do this whole, like, you bind to it, and multiple things can bind to it. So when you broadcast it, it will be everything that has bound to it will be called at once. So that's what multicast does.
So if it's not multicast, you can't even bind like multiple functions, even if it's separate instances.
No.
Right.
If it's separate, like, you can make like 5 variables of that delegate and then bind, like, you add one to each variable. But if you only had one variable, then that means you can only call one function.
So yeah, if you add like the component to another object, it would only call like the first object, I'm assuming.
It will,
or like the first code.
Then you wouldn't be able to. First of all, you wouldn't be able to do this. You would have to set it like through a function or something. But then once it's set, then that's what it is. Like, you set it to a function, that's the only function that's going to be called. And if you later set it to another function, then that's the only function that's going to be called.
Cool.
So it's just a pointer to one single function, which is sometimes useful, sometimes not. It's, you know, different use cases.
So if you wanted to subscribe to this for code, that's when you use the a dynamic macro.
Sorry, can you say it again?
So if I would like to subscribe to this for code, then that's when you can use that add dynamic macro.
Yes, exactly. That's what the add dynamic does.
All
then
right,
it's sort of converted to a dynamic function, essentially. It's magic going on, but yeah. If you want to bind to a dynamic delegate, then you got to do add dynamic.
All right.
Cool. Makes
But
sense.
yeah, this is the most common way of declaring delegates in Unreal. By far the most common. Cool. All right, let's take 10 minutes. So I'll see you guys back at 14. See you then.
See ya.